Good morning, everybody. So today you guys are going to be going over scientific notation as well as another quick review on ordering real numbers. So we're going to go over our notes and then we're going to do some practice problems. So let's take a look at example A. So we have a question. It says to sort the pile you need to order the lengths from least to greatest. Ronald's most desirable piece of wood is one with the shortest length. So first I know I need to go from least to greatest, right? So I have all these numbers. What I am going to do, I'm going to use my scientific calculator. So you can go to Desmos/scientific, and then it'll pop up the calculator for you. So I'm going to convert all of these to decimals. So I know if it is larger or smaller. I want them all in the same form. So first I'm going to do 3 divided by 25. And I get 0.12. So I'm going to write the decimal form up under each number. Next I'm going to do the square root of 3 divided by 11. Now it's important to make sure you press this arrow so you're not under the radical sign anymore, because that'll give you a different answer. I'm going to round to the nearest tenth. So on my calculator, it says 0.157. So if I round, that is 1600ths. Then we should all know what 9 divided by 100 is. But I'm going to show you how to do it on the calculator. Have 0.09. And then next you have pi divided by 24. And as I stated before, I'm going to round to the nearest tenths place. So I have 0.13. All right. So I want to put these in order from least to greatest. If you need, you can always draw a number line to help you. So I have 1, 2, 3. We're not working with any negatives, but if you need to draw a number line and place them, go ahead. My smallest number would be 0.09. So I have 0.09, which is really 9 over 100. Okay. Then my next smallest number would be 3 over 25. The next smallest number is pi divided by 24. And the greatest number is going to be the square root of 3 over 11. The question says Ronald's most desirable piece of wood is the one with the shortest length. My shortest length is 9 over 100. So that is the piece Ronald would like to have. Let's take a look at example B. It says Ronald's most desirable piece of wood is the value that is greater than 23/4. So the first thing I'm going to do is figure out what 23/4 is. So I'm going to do 23 divided by 4. And that is 5.75. We want to know which one is greater than that. So 0.07, that's not greater than 5.75. Then I have 23/6. So I'm going to do 23 divided by 6. And that's 3.83 repeating. Then I have 29 divided by 5. So 29, Let's clear that because it doesn't want to work with us. 29 divided by 5, and that's 5.8. And then with your percentages, I have 165%. I just moved my decimal 2 places to the left, and that's 1.65. And you could also put that in the calculator. You can put 100, so let's move to the next. You can put 165%, or 165 divided by 100. On your scientific calculator at school, it'll let you just put 165%. So which number is greater than 23 fourths? It would be 29 fifths. 29 fifths is greater than 23 fourths because it's worth 5.8. Next, we are going to talk about scientific notation. So the important thing about scientific notation, one important thing to note is it is a way to write really big or really small numbers. So I have this anchor chart here, and it talks about scientific notation. So this number here would be your base of your number. And so that is always going to be a number equal to or greater than 1 and less than 10. So it needs to be between 1 and 10, okay? And you're multiplying by a base of 10, and your exponent is going to be the number that you're moving your decimal by. So your exponent is either going to be positive or negative. So when you're writing really, really large numbers, your exponent will be positive. When you're writing really small numbers, your exponent will be negative. So let's take a look at our notes. So I have 4.5 times 10 to the ninth power. So since my exponent is positive, it's going to be a large number. So this is scientific notation here. Okay, I'm going to write it in standard form. Okay, so since this is a large number, I have 4.5 times 10 to the ninth power. Since this is a large number, I will be going to the right. I will be moving this decimal to the right. Since it's to the ninth power, I'm going to move my decimal 9 times. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to put in my placement holders of zeros. Okay, and this is how I get my standard form. So this is how you would write this number largely. Okay. This is how you would write this number in standard form. So if it is a large number, you're moving your decimal to the right, however many times your exponent tells you to. Next, I have a negative exponent. So in standard form, I know this is going to be a small number. So I'm going to write a number. And since this is a smaller number, I am moving my decimal to the left. So I have negative 5. I'm going to move my decimal 5 times. So that's 1, 2, 3, 4, 5. Put in my placement holders. And my answer in standard form is here. So that is how you go from scientific notation to standard formation. Okay. Next, I'm going to go from standard form to scientific. So this is known as your standard. When you are going from standard to scientific, you're moving your decimal in opposite directions. So if you're moving a decimal for a very large number, remember your decimal always goes at the end, and then you're going to move it to the left. So 1, 2, 3, 4, 5, 6, 7, 8. So in scientific notation, it will be 9.2 times 10 to the 8th power. Remember, my exponent is going to be positive because my number is large. It's also important to note that you are going to move your decimal until you only have one number in front of the decimal. So you're going to move it as many times as you need to until you have one number in the ones place. Okay? So when you're going from standard to scientific, when you're going from standard to scientific notation, and it's a large number, you move your decimal to the left. Now, when you're going for a very small number, you're going to move your decimal to the right. And remember, you're going to move it until you only have one whole number in front, one natural number in front of your decimal. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now that I write it in scientific notation, it's going to be 1.673 times 10 to the negative 18th power. I believe it was 18. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So in scientific notation, it's to the negative 18th power. Remember that since your number is really small, your exponent is negative. So now, at this time, you're going to complete your assignment on your Google Sheets. So as you can see here, you have some tables to fill out. So first, you're going to write your answers in. You're going to fill in this first table. So if you were given scientific notation, you need to write it in standard form. Okay? If you're given standard form, you need to write it in scientific notation. One way to write it in scientific notation on your sheets is you're going to use this arrow, and that indicates an exponent, and you put your exponent right after it. Next, you're going to complete this table. So here you have a question. You are given all of these wrenches. You need to figure out the approximate value, round to the nearest tenth, okay? And then you are going to tell me if it fits within the specifications of these two numbers. After you do that, you are then going to come over here and tell me which wrenches should be included, and you can do that just by using the numbers. So you don't have to type in 3.2 times 10 to the first power. You can just type in 1, 2, 3, or 4, 5, 6, 7, 8. Whichever ones are included, type that in here. And if you're correct, remember your answers will change colors. You will explain your findings here. Remember, this will not change colors because the answers will vary. Have a good one.